We've seen that working with the production function, and in particular with the simplified form of the production function, the two-dimensional production function, already enables us to say some important things about the process of economic growth. So this observation that the path to economic growth can be different for different economies has some important implications. It has some important implications when we look at some real-world success stories, in particular a debate that has been carried on about what is important, what has been important for growth in the economies of East Asia, Hong Kong, Taiwan, Singapore, for example. There, as we'll see, growth has been fuelled, particularly in the early stages of growth, by what's called capital accumulation, by building up, essentially, the capital-labour ratio. So what's the debate? The debate is whether those economies that have experienced economic growth as a result of building up their capital-labour ratios can rely on that continuing going forward into the future. Because of diminishing marginal productivity of capital, what works in terms of generating growth in the early stages of an economy's development cannot necessarily be relied on to generate growth in subsequent later stages of development. And at some point, governments in economies are going to have to think about whether what's worked in the past, growing that capital-labour ratio, will continue to work in the future. And policies designed to promote growth may have to be reoriented towards promoting total factor productivity as opposed to growing the capital-labour ratio. This in some sense is a choice, a strategy choice that all economies have to face. But so far we've been operating at the level of theory, drawing diagrams, writing down mathematical representations. It all makes sense from a logical point of view, but do we actually have any evidence that these ideas actually have any currency in the real world? Is it true that economies in their initial stages of growth relied on capital accumulation, relied on growing their capital-labour ratios? And is it true that more mature economies, economies with longer histories of growth, have relied more on total factor productivity? There is in fact a very simple analytical technique widely used that will enable us very quickly to provide an answer to that question. It's a technique known as growth accounting. And I just want to quickly take you through this because I want to show you some interesting empirical evidence, some real-world evidence that supports the kind of implications and ideas I've been talking about. So growth accounting is a technique. It's a technique that enables us to look at the growth history of an economy and ask some important fundamental questions about that history. In particular, what have been the main factors at work that have produced the economic growth outcomes that we see in the real world. The starting point, and you won't be surprised to hear this, is the production function. Now previously we've just worked with very general specifications of the production function. Growth accounting relies on a very specific form of the production function. By that I mean a very special type of mathematical representation. It's something known as the Cobb-Douglas production function. It's named after the scholars who first developed this idea. And it is one of the most widely used analytical tools across all branches of economics. Now it's going to look a little daunting when you first see it, but remember we're not really doing anything different than what we've done in our previous work on production functions, other than writing down a very specific mathematical representation. Instead of working with a general production function, we're working with a special type of production function. It's not the only type of production function that economists work with. There's a whole family of production functions. This one turns out to be a pretty convenient one to work with, and it is important in this growth accounting exercise that I'm going to describe for you. The mathematical representation of the Cobb-Douglas production function is here. Most of that you've seen before. A is total factor productivity, K is capital, L is labour, Y is output. I've used uppercase letters here, but all of this material, these variables should be interpreted as being real variables. The thing I haven't shown you before, the part of that expression that's unfamiliar, is that term alpha. Now this has nothing to do with the rate of economic growth that I talked about before. This is an entirely separate concept. Alpha is just a number. It's just a number that takes a value somewhere between 0 and 1. For example, a very typical number that's used might be 0.25. So that's all it is. It's a number that feeds into the Cobb-Douglas production function that enables the Cobb-Douglas production function to very closely replicate real-world features that we see. To convince you of the practical usefulness of this Cobb-Douglas production function, here is a production table that I've constructed feeding different values of capital and labour into an expression that takes the Cobb-Douglas form. And I'll leave it to you to check that the numbers we get out of this exercise are consistent with diminishing marginal productivity and also consistent with constant returns to scale. In fact, you can show mathematically, and there are many textbooks that do exactly this, that the Cobb-Douglas production function, as long as you assume that that number alpha is between 0 and 1, will always be consistent with those two characteristics of real-world production, diminishing marginal productivity and constant returns to scale. The reason economists work so often with the Cobb-Douglas production function is that it is able to mimic what we observe in the real world in terms of those two characteristics. So I'm now going to show you how this Cobb-Douglas production function can be used to undertake a growth accounting exercise. Remember, what we're doing in growth accounting is we want a technique, an analytical tool, to enable us to examine the economic growth history of an economy and to determine what have been the most important factors that have contributed to that economic growth. So here I've written the Cobb-Douglas production function for you. What I'm going to do is put a little superscript T next to output, next to total factor productivity, next to capital, and next to labour. Because I now want to make it perfectly clear that what I'm talking about is a production process that takes place over a period which we will call period T. If I do that, I can then also do exactly the same thing for output not in period T, but in the previous period, which we'll call period T minus 1. So period T could be 2013, T minus 1 would be 2012. So the output in the previous period must have been generated by whatever total factor productivity was in the previous period, times the previous period's capital stock raised to alpha, times the previous period's labour raised to 1 raised to 1 minus alpha. And now I'm going to draw on some of that mathematics that I showed you earlier about what happens when you take a logarithmic transformation of an economic relationship. Now again, I don't want you to be too stressed out about this if it's been some time since you've studied high school maths, or if all this looks a bit strange to you. It's the result, the bottom line, that I want to focus on. So if you're a bit unfamiliar, a bit rusty on what it means to take a natural log of a variable, then I wouldn't worry too much about it, as long as you appreciate where we get to when we make this mathematical operation. So let me take the natural log, and we'll go back to this first Cobb-Douglas production function of output in period t. That can be written as the natural log of total factor productivity plus alpha times the natural log of the capital stock plus 1 minus alpha times the natural log of labour. And I can do exactly the same logarithmic transformation for the previous period's Cobb-Douglas production function. So on the right-hand side, we'll have the natural log of total factor productivity in that previous period plus alpha times the natural log of capital in that previous period plus 1 minus alpha times the natural log of labour in that previous period. Well, why bother? Why do that? I want to do that because I want to subtract those two expressions. I want to look at, in other words, the difference between the natural log in period t and the natural log in period t minus 1. If I do that, natural log of output in period t minus the natural log of output in period t minus 1, what do I get on the right-hand side? I'll get the natural log of total factor productivity in period t minus the natural log of total factor productivity in the previous period plus alpha times the natural log of capital period t minus alpha times the natural log of capital in period t minus 1 plus 1 minus alpha times the natural log of labour in period t minus 1 minus alpha times the natural log in period t minus 1. And let me just quarantine a bit of this slide so it doesn't become too confusing for you, because we have in fact just about finished. Because remember, if you take the difference of, let's write it as difference of variables when they're expressed in logs, what you actually end up with is the growth rate. Remember, that's true if our variable is growing at an exponential trend, which economic variables almost always do. So what we have in this expression here, on the left-hand side, we have the difference between the log of output this period and the log of output in the previous period. That, in fact, is the growth rate of output. And on the right-hand side, when we take the logs of total factor productivity this period and total factor productivity in the previous period, and take the difference between those two logs, that's the growth rate of output. Sorry, that's the growth rate of total factor productivity. Just as a shorthand notation, let me write that as the percentage change in total factor productivity. So remember, the Greek letter delta is my shorthand for change. Next, we have Next we have alpha. Now here we have the natural logarithms of capital this period and the previous period. We're looking at their difference, so we have alpha times the percentage change of the capital stock, or if you like, the growth rate of the capital stock. And similarly, when we look at labour, we have 1 minus alpha times the change in labour, times the change in the natural log of labour this period and the natural log of labour in the previous period. That's the growth rate in labour. And what you're looking at is called the growth accounting equation. It's saying something incredibly important. On the left-hand side, we have the overall growth rate of output in the economy, the rate of economic growth. And on the right-hand side, we've been able to divide that growth up into 3 distinct factors. The first factor, growth in total factor productivity. The second factor, growth in the capital stock. The third factor, growth in labour. But note the extent to which either the growth in the capital stock or growth in labour influences the economic growth rate is going to depend on the value of alpha. So that value of alpha is actually pretty important in this analysis. But it's really the main idea I want to get across here. An economy's growth rate, using this growth accounting technique, as long as you're able to measure all of these variables, can be divided between total factor productivity growth, capital growth, and labour growth. And it's using this equation that economists go out and examine the economic growth history of various economies to try to determine in the historical record what's been most important for an economy's actual growth. Is it total factor productivity? Is it capital? Is it labour? Is one of these factors more important than the other? This technique actually enables you to conduct that exercise. And this exercise has been done very, very frequently. You won't have to look too far in the economic literature to find examples of exactly this. So here's one study from the research literature that I wanted to bring to your attention, which has done exactly what I described in the previous slide for a variety of economies. And I want you to note the following. Over the time period that we're looking at, that's the time period where those 5 economies experienced their initial and often quite spectacular periods of economic growth. And look what was most important: capital. The share of capital in driving economic growth was dominant for these economies in that period. And total factor productivity, less so. But when we look at the more mature economies with much longer histories of economic growth, we'll see that, yes, capital was important, but for these economies, the most significant factor driving their economic growth, total factor productivity. This is exactly what we concluded from our 2-dimensional production function, and it's our first important lesson about economic growth. So let's just stop and summarise a little bit about what we've done. And we've actually done a lot, we really have. So the way macroeconomists approach the study of economic growth is to do so in a very systematic, simplified fashion, building on the analytical tool of the production function. A very simple representation of something that we know in the real world is incredibly complex. The bringing together of capital and labour and many, many other factors in a way that produces output. A key characteristic both of real-world production and this analytical tool, the production function, is the idea of diminishing marginal productivity. And our first and very important lesson about economic growth is that if you were talking about an economy that's beginning its process of growth, so that's starting from a base of a relatively low capital-labour ratio, then the path to economic growth, to significant growth, in other words, in per capita income, is to boost that capital-labour ratio. If you're talking about an economy in a different stage of its development, where it has already achieved a relatively high capital-labour ratio, the path to further economic growth is not going to be growing the capital-labour ratio, it's going to be through total factor productivity.